Hello everyone, I am Ranjit J, Assistant Professor in Department of Information Science Engineering, SJB Institute of Technology. In this semester, I'll be handling analog and digital electronics for you all. In this subject, we'll be having totally 5 models. Very first model, we will start with learning about JFETs, MOSFETs and operational amplifiers. Next, we'll be learning about basic gates and different kind of wave shaping circuits. And next, at last, we'll be learning about flip-flops in this subject. If you want to learn this analog and digital electronics, one should have a strong basics on basic electronics as well as logic gates. So here, if you want to learn this subject, you are having a lot of advantages. In the future, if you are dreaming about to become an embedded system engineer as well as a hardware engineer, this subject really teach a strong basics about what are the different components you will use for the construction of computer. Thank you, Monica.
Okay, the next experiment, realize a JK master slave flip-flop using NAND gates and verify its truth table and implement the same in HDL. That means we have to do both hardware and software program, and first we will go for the hardware program, and first we have to know what is flip-flop. Generally flip-flop is you can use for the storage purpose. It is a bistable device which is able to store either 0 or 1. Suppose if you want to store 2 bits means we have to use 2 flip-flops. And come to the types, and among JK is one of the type of the flip-flop, and J is nothing but similar to the set, and K is nothing but reset. And here the concept master slave we are using, because we are using the 2 flip-flops. One will be active on the positive clock pulse, another one we can be active on the negative clock pulse. For that we are using a master and slave. A slave should be depending on the output of the master, and during the positive of the cycle the master should be enabled, and during the negative of the cycle the slave should be the enable and master should become disabled. Okay, and here this experiment we have to implement by using only the NAND gates. Okay, now I will go for the experiment, and this is for this experiment we need 2 pin diagrams. One 7400, that is a 2 input NAND gate, and we are using one more IC, that is 7410, it is a 3 input NAND gate. And I think already I given the pin diagram, the same pin diagrams, and from this we can use 1, 2 and 13 are the input of the first gate, and 12 is the output of the first gate, and 3, 4, 5 are the input of the second gate, 6 is the output, and from third input of the 3 input NAND gate we can use, that is a 9, 10, 11 and 8 is the output. These 2 pin diagrams we are using for this experiment. And come to the circuit diagram, and I told this part we can call as a 1 flip-flop, and this is 1 flip-flop, and we have to make the clock. This entire thing should become the clocked flip-flop, and it is another clock. Here it will be here we are using the clock, and here we are applying the clock here. This is a clock pin, and we are using one inverter for this. For inverter also we are using NAND gate only, and this will be enabled during the positive of the pulse, and this will be enabled during the negative of the pulse. And we can observe here the slave should be depends on the output of the master. Okay, this part completely we can call master, this part we can completely call as a slave, but slave should be depending on the master. Now I will go for, this is a truth table for the JK flip-flop, and when it is 0 0 it should be no change, there is nothing but it can be display the previous value what it should be stored, same value it should be displayed, because it is a sequential circuit. Now come to the, when J is 0 and K is 1 means it is a reset. At the time you will get Q as 0 and Q bar as 1, and when it is J is 1 means it is a set. At that time Q becomes 1 and Q bar becomes 0, and when it is 1 1 means it is a toggle state, it should be changing the states. Q is 0 means Q bar is 1, again it should Q becomes 1 and Q bar is becomes 0, that is it going to toggling. Okay, now we will do the experiment this one, and here we have a 3 input. For that I am going to use 7410 gate, and this I am going to inserting here. You can use any one of the slots among these, and I am going to use, this is for 7410, and that is a 3 input NAND gate. It is also a 14 pin IC. From this last row I am not going to use, so that while we have to use up to connections up to here. After 7 again 8 counts from this side. Next 2 more ICs, that is a 7400. It is a 2 input NAND gates, and I will use, here we have the 3 slots and here also we have the 2 slots. You can use any one of the slots from this 5. I will go for this one, which is your comfortable, go for that one. Same thing, while inserting, the notch is towards the top and you can lock it. Now see, it is locked. Now take one more IC, that is a 7400. It is a 2 input NAND gate, and this is also locked. All 3 what we inserted ICs we can use. For this IC this slot, and for this one, and for this IC this is this part. Now all 3 took the 14 pin ICs, so that 1 to 7 and again 8 to 14. Now we take the patch cords, and first what I will do, I will go for the easy way. First I will connect the power supply of all 3 ICs. The 7 is negative, that is a ground, and 14, 7, 8, 9, 10, 11, 12, 13, 14. This is, I am going to connect the plus VCC, that is a positive. And from this IC, 7 is ground and 14 is plus VCC. And if you connect opposite now, then IC will become burned, so that we have to observe the pin diagram. According to pin diagrams only we have to connect the power supply. If you make the wrong connection, then IC will be burned. While connecting, you have to observe. See, now the power connection is over. Now come to the circuit diagram, which is the pins we have. This is a 3 input NAND gate. 1, 2, 13 are the inputs. Among that, 2 is the J, that is the input. I will take the 2 as J. I told you it should be these pins we can be used for the logical inputs. You can use any one of the input, any one from this row. And again I will take from the second gate, 4 is the K, that is the pin number 4. I will take the K. These 2 are the inputs. Now come to the 13 and pin number 3. We should be short it. 3 and 13, short it, that should be connected to clock. This is the 3. You can 3 and 13 are shorted. I connected to clock. This is the TTL clocks. We can use the clock. If you use the low range, then it should be displayed slowly. If you use high range, then it should become, it is difficult to observe the output, so that I will go for the low range only, that is 1 Hz. And next, pin number 1 will go to the pin number 8 of second IC of the 7400. I will connect the 1, that is go to pin number 8 of the second 7400 IC. This is the pin number 8. I will connect to here. And next, pin number 5 will go to the pin number 6 of second IC. Pin number 5 of 7410 will go to pin number 6 of 7400. Now the 6 is Q and this 8 is Q bar. I will connect those. 6 is Q. I will connect to the output. This is, I will take the output, that is a Q, and the next one is pin number 8 of 7400, that should be the Q bar, and here we have the 8, and this I will take the Q bar. Now come to the pin number 12 of 7410. We will go to the pin number 1 of 7400 first IC, and pin number 6 of 7410, that will go to the pin number 5 of 7400 first IC, and take pin number 2 of 7400 first IC to pin number 6 of same IC, and pin number 4 and 3 of the same IC 7400 should short it, and this part is over. Now come to the clock. 9 and 10 of pin number 7400 first IC, short it, and 8 is the output. That 8 will go to the clock of the slave. For that you can leave, later you should connect. And now come to here, a pin number 3 of 7400 first IC will be goes to the pin number 12 of same IC. And pin number 6 will go to the pin number 6 will go to the 2 of 7400 second IC. And pin number 1 of second IC, that is connected to pin number 13 of 7400 first IC. And what the output we taken from the first IC, that is the 8, that is the clock input of the second one, that is 13 and 1 we are shorted. Now there we should be connect either 1 or 13. I will connect to the 1 of the second IC 7400. Okay, next the 11, that will be go to the pin number 11 of the 7400 first IC will go to the pin number 4 of second IC. And pin number 3 of second IC will goes to the pin number 10, 8, 9, 10, and 9 and 6 short it, 9 and 6. It should be little bit complicated, but you have to connect according to the pin diagram slowly. And don't confuse, more connections are there. Connect slowly according to pin diagram, you will get. Next, 8 to 5, and that will goes to the 8 of 7400. Okay, now the connections are over. Now we have to check by switch on the board, and these are the JK, and both are 00 here, and here it should be display either this is 0 or 1 or 1 or 0. It is the previous, what the previous value. And if you make J as 1 means the Q as 1 and Q bar as 0, and if you make J as 0 and Q as 1 means the Q bar should become 1 and Q is 0. If you make both are 1 1, it should be toggling like this. If you can observe here, it should be some blinking. This is blinking one time, this one. If you have some loose connections means you will get like this, or if you have correctly means it will get the correct outputs. See here, it should be changing. This we can call as a toggling. Thank you. This is the way we have to do the experiments, and it is end of the experiments. And here we use only the NAND gates. We will not use any basic gates. We are used according to this. Same thing we have to do in software also. Same diagram we have to take and we have to do also. This is the hardware part. Okay. Thank you.